Hello viewers, welcome to another exciting episode as the continuation of tutorial on trigonometry continues. We are still on the application of trigonometry. Simply put, questions that are not directly looking like as a trigonometry questions until we draw a diagram and apply the concept of trigonometry into it. This is episode number 4 in that regard. So we are having a question: a pole and a stick stand vertically on a level ground. The stick is 25 centimeters long and cast, I think this will be S, right? And cast a shadow of length 20 centimeters. If the pole cast a shadow of length 5 meters, what is the height of the pole? So we want to see how we can put that across. We are having a stick and a pole, which are all standing vertical. So let's make a sketch, not directly on this first. Let's see if I have a stick and a pole, which are on the same level ground. Then the pole and the stick stack. Okay, the stick is 25 centimeters long and casts a shadow of length this. Then if the pole casts a shadow of length this. Now remember, if we have the two poles on the ground, for them to cast a shadow, the shadow is going to be of the same direction because the sun will be at one side of where they are. So let's imagine the sun is here. If the sun is here, their shadow falls to the right. All right. Now, if the shadow will fall to the right, if the time is the same, their height will be considered in the shadow, because the taller one will give you a longer shadow because the sun is at the same side, or they are all at the same time, 5 o'clock, 3 o'clock, 1 o'clock. So the shadow will be depending on their height. So if we are using this as pole, this as a stick, and they are going to cast a shadow on the ground, the one that will cast the longest shadow will tell us that that is the one that is the longest object. So let's see the shadow they are being casted. The stick of a length, we cannot tell that of the pole, so let's go. Cast a shadow of length 20 centimeters. Then a pole also casts a shadow of 5 meters. Centimeters, 5 meters. So 5 meters in centimeters will be 500 what? Centimeters. So it means that for the pole will be longer than the stick, because the stick casts only 20 centimeter shadow. Okay, so if that is the case, if the shadow from here to this place, let me end it here. If this is the 500 centimeters, then this pole will cast a shadow in a shorter direction. So let's say I indicate this line here. So this is the stick. If the stick is here, the shadow will only fall to this side, and it means that this pole will be longer in length. So the shadow fall to this place, the shadow fall to this place. So if I connect their height to where the shadow is falling, this will give me the right angle triangle that I'm having. So a stick, a pole, shadow. This is how it's going to be. I don't know if you have gotten the idea in it, because they will not fall. The shadow will not fall at opposite side of where they are, because the sun is at one side, so the shadow will fall in that regard. So let me redraw this as we look at the direction. So you can see, drawing this on a nice scale, this is how the diagram will look like. This represents the stick with each length and each shadow being 20, 25 and 20 respectively. The pole, the length is not known because we are asked to find it, the height. Then the shadow cast will be 500 centimeters. So this will give us the idea of a similar triangle. So we can say that from similar triangle principle or property, we are going to say that the vertical heights are going to be corresponding. So the ratio of their side should be equal to the ratio of the horizontal side. So if I begin with this as the height of the pole, it should be divided by the height of the stick, which is 25. This ratio should be the same as the length of shadow cast by the pole, which is 500, divided by the length of shadow cast by the stick, which will be 20, all in centimeters. So what do? This become a ratio we can cross multiply. So h times 20 will give us 20h, and that will be equals to 25 times what? 500. So what can I do? I'll divide through by h. So divide by 20, not h. H is the variable. So if you divide that, you should be having 20h over 20 equals to, let me still maintain, 25 times 500 over 20. So h will be equals to, remember this 0 will cancel this, so you'll be left with 25 times 25, and that will be 625, all in what? Centimeters. But you can see that the pole casts a shadow in meters. So here we know that 1 meter equals to 100 centimeters. That is why 5 meters give us the 500 centimeters. So we need to convert this value back into meters. So that means that the height of the pole is going to be, if you divide this by the 100, if you are moving from meters to centimeters, you multiply by 100. From centimeters to meters, you divide. So as you divide 1, 2, you'll be having 6.25 meters. So that will be the length of the pole before it casts a shadow of 500 a shadow of 5 meters on the ground, which is equivalent of 500 centimeters. I guess you understand the concept. So if you look at the question carefully and its calculation, you can see that we don't really apply the trigonometric concept. The only concept we deal with is the fact that the diagram is what? A right angle triangle, which is the base for which we calculate trigonometric properties. This is also a similar triangle which we make use of what? A right angle triangle. We can find the angle it formed on the ground as well and use trigonometry to find the height, just like we did in the previous episode. Share, comment, and subscribe.